Hello team, today we are going to discuss one more implementation of list interface. I'm talking about LinkedList. In this lesson we are going to learn how LinkedList works. We are going to review the source code and understand when we are going to use it. Also, we'll compare LinkedList and ArrayList to provide you with the answer what list implementation you are going to use most of the times. Besides that, today in lesson we are going to have a lot of practice and I will share with you home tasks that will help you to practice your knowledge in lists. Let's start. And first of all, let's understand how linked list works and why it is called so. This is double linked list. Why it double linked? Let's look at the slide. This container consists of multiple objects of node type that connected between each other. Each node contains some data, link to the previous node and link to the next node. That's why each node has two links. That's where the name of the container comes from, linked list. It is double linked because each node has the links to the next and previous element. Does it make sense now? Let's review the real example of linked list. Take a look at the slide please. For example, we have our first node, A node. It contains value 1000. Take into account this is the first element, the link to previous element is null. But link to the next element is linked to the B node. B node also contains value, that is 2000. Link to the previous node, that is A node. And link to the next node, C node. C node is the last one, that's why link to the next node has null value. And on the slide you can see that linked list always stores the reference to the first and the last node. It is clear now how a linked list is built? Understanding of this will help you a lot in understanding where and when you might want to use linked list. To proceed our lesson today, I suggest investigating the source code of the linked list. Here is the source code of the linked list class. As you remember from the previous lesson, it extends abstract sequential list that contains implementation of some list methods. Here you may see two fields of node type. I believe from their names it is clear where they are referencing to. The linked list always stores the reference to the first and the last element. Let's investigate how adding new element to the collection works. I want to open add method. Here it is. We can see that link last method is invoked here. Okay, let me investigate that one. New variable of the node type is created and initialized with the last node in the linked list. After that, new node object is created. Special constructor is called. We are passing reference to the last node, element that we want to add, and null value. Let me open this constructor to investigate what is happening there. And now we may receive two answers. The first answer is on the question what is node class. As you can see, node is a static nested class. And it's private. That means that instances of the node class can be created only from the linked list class. You also may notice that it is not so big and it doesn't have any behavior, only state. The state of the node class is described in three fields. They are item, next, and previous. And the second answer is in this constructor. So, the first argument is used to initialize previous variable. The second method argument is used to initialize the value of the current node, and the third method argument is used to initialize the next variable. Now when we know this, let's get back to the add method. And when new node is created, last variable is pointing out to the new node. And in case last node was null, that means list was empty. Thus, new node should become the first element in the list. If no, then we have to change the next reference in the node that was the last not so much time ago. What I want you to understand? I want you to understand that to insert elements in linked list, it is enough just to change references to the previous and the next element. That's it. If you remember ArrayList that we learned in previous lesson, you should already know that in ArrayList we always need to copy values from previous array and to create new arrays if we want either remove elements from the middle or beginning of the list or to insert elements at the beginning or in the middle of the list. In the linked list, these operations may be done much faster and significantly easier. Also, I'd like you to pay attention to the fact that linked list implements DAG interface. Let me open it. DAG interface extends queue. This is lesson not about queue and DAG interface, but it is hard not to mention that linked list is also one of the most popular implementations of the queue interface. And to be honest, I used linked list more often when I needed implementation of the queue, but not implementation of the list. Why? I'm going to explain you this in a minute. So, knowing this fact, don't feel wondered why linked list also has such methods as add first, add last, remove first, remove last, get first, get last, and others. Now you know that linked list must give implementations to this method since it implements DAG interface. We will not review these methods today since this is lesson about implementation of the list interface, but we'll discuss the other methods for sure during the lessons about queue, so don't worry. Now, I suggest practicing a bit with using linked list and ArrayList. For the sake of the demo, before the lesson I created this demo file. I will leave link to it in the lesson attachments, and if you have all my training project cloned from the GitHub, just pull the latest changes. Let me also run this program and we'll explore console output together. Okay, at the beginning here I created two variables of type list, both of them initialized with ArrayList objects. Do not forget to do imports. Eclipse will remind you to do that, so don't worry. You also can see that the first list here is underlined with yellow line, the same as ArrayList here. But in the next line there are no any warnings. What is the difference between these two declarations? Probably you already saw in the source code this diamond operator, but you couldn't understand what does that mean. Let me explain you this on the next example. I add string object to the list 1, and I also add integer object to the list 1. Now my list 1 contains objects of different types, but all of them are compatible with the one type, object. That's why when we want to get element of this container, we always get object of type object. Can you understand why? Because Java compiler doesn't know what object will be on the first index in the list and what its type. Now let's look at the second list. I also can add string in it. But I can't add integer, because this would cause compilation error. Why? This is called generic mechanism. We're going to have separate lesson where I'm going to describe you generics in detail, but right now you have to understand it at least on the high level, because this will help you during the homework implementation. Here in diamond operator we specify type of elements in this list. That is sign for our compilator that in this list we will store only string objects. We also have to specify diamond operator here next to specific collection implementation. Before the Java version 7, engineers should also specify type here. But after Java version 7, in case type is the same as it is specified for variable, we can keep it empty. This would be the same as in case we would specify type here. That's why compilator allows only add string objects there. Pretty cool feature. Don't you think so? This saves developer nerves when we get object from the container, call some method on it, and we see some exception, and program stops execution, because somebody in some other method put in the container object of incompatible type. And when compilator is sure that we'll store only string objects there, we also can retrieve objects of the string type. For example, here when I get element from 0 index, I get object of string type. Hope this brings some clarity on how you may use diamond operator. More advanced scenarios and how generics work will be reviewed during the separate lesson. Okay, let's move on. Here you may see that I initialized my variable of list type with linked list object. And this is one of the advantages of Java Collections framework. Here it is. We may change implementation of the list, but the application programming interface is the same. I still may use the same methods and count on the same result. That's why all examples that you are going to see in this and in the next lessons will be the same for different implementations of the specific interfaces. For example, if we are reviewing list interface, you may use different implementations of the list. All of them have the same set of methods, but the way how these methods works inside are different, and that may impact on your decision which list implementation to choose. Does it make sense? Now, let me share with you the tip and the popular way to initialize some lists. All lists implementation have constructors that takes collection of elements and initialize new list with these elements. Arrays class has addList method that takes multiple parameters of the same type and returns the list, which in turn we use here to pass it to the constructor of ArrayList. So, here's the example how you can initialize your list with multiple elements in one line. For learning and debugging purposes, you always may pass list implementations to the println method, because all list implementations have toString method overridden to display elements in such way as you can see here in console. Also, another important and practical thing to share with you. All collection implementations can be used in for each loop. I believe that you remember that collection interface implements iterable interface. This fact guarantees that each implementation of collection should have iterator method that will return iterator object that knows how to iterate over the collection of elements. That's why all collections can be used in for each loops according to Java syntax, and you can see example here. So, now you remember that all arrays and everything that implements iterable interface, even if this is your own custom class, may be used in for each loops. And here you can see example of clear method. What I would recommend is to play with other methods like I do here. Call clear method, call other methods and investigate console output. Writing code and calling different methods will help you to understand material better, and probably that would cause some questions, and I will be always happy to answer those. Now, when you know how to use list implementations in Java source code, I suggest understanding what list implementations you have to use in which particular case. And to make a choice, I'd like to explain you what big O notation is. Big O notation is a mathematical notation that describes the limiting behavior of a function when the argument tends towards a particular value or infinity. We are not going to do math in this course, but we need to understand big O notation while working with different implementations of collections. In computer science, big O notation is used to classify algorithms according to how their runtime or space requirements grow as the input size grows. In very simple words, big O notation can tell us how efficient algorithm as number of elements that algorithm work with increases. We are going to use only few classes of functions. Let me explain you what they mean. O1. That is constant. For example, get an element from array by its index is always constant. On. That is linear class. That means that performance of the function directly depends on the number of elements. For example, function of finding element in unsorted array has On notation, because you have to check each element one by one to find the exactly one you need. This operation takes time, and the time will depend on the number of elements. Does it make sense now? O logarithm n. That is logarithmic class. Function of finding element in binary tree has O log n notation. For example, imagine that you have sorted array of elements. If you are looking for specific value, you can predict in which part of the array it is most likely stored, and you shouldn't iterate exactly over each element. We are going to learn what binary trees are in the next lessons. Right now, you can understand this as something what still depends on the number of elements, but the dependency is not linear. I try to say this as easy as possible without going deep in mathematics. Believe me, when you will see this on practice, that would be much easier. Now, I'd like to answer the question which implementation of list to use and when. The first thing you have to answer during the interview in case you would be asked what would you use, linked list or array list. You should ask in which environment we plan to use list implementations and regarding amount of data. To answer when to use which implementation, let's review performance of each list implementation, and based on this, we will give an answer. Now let's compare big O notation of ArrayList and LinkedList. Here on the slide you can see big O notation for different operations for array and linked lists. Let me go over each one. Get operation in ArrayList is constant. That's why we see here O1 notation. When on the other hand, getElement from linked list has linear complexity. And I want you to not memorize big O notation, but understand it instead. Can you understand why retrieving elements from linked list is a linear function class? Correct, because we have linked list without indices. And to get any specific element, we should iterate over each element unless we would reach exactly the one that we need. Linked list also defines from which side of the list to start. If index in the second half of the list, then iteration starts from the end of the list. In case index is in the first half of the list, then iteration starts from the beginning. Does it make sense? Okay, then let's move further. Add elements to the list. ArrayList adds always for constant amount of time, the same as linked list. I'd like to make a note here. This notation is from the book Java Generics and Collections by Philip Wadler. You may find it on the internet if you wish, and I want to say that this is an average value listed here. Why? Because adding elements to the end would take constant amount of time in both containers, but for ArrayList you already know one exception. That is the case when arrays inside the ArrayList is expanded and additional time is needed to copy all elements from old array to the new array. Also, there is another note. Adding elements at the beginning or in the middle of ArrayList would also trigger creation of the new array, and depends on the actual size of the array, this can take some time. Even despite native method written on C++ is used to copy an array and it works really fast, on huge amount of data that may cause some performance issues. That is something what you have to remember. Let's move on. Remove operation. This algorithm in ArrayList is linear, the same as in linked list. But in general, it should work faster in linked list on huge amount of data. Because to remove element from the middle or beginning of the ArrayList, we have to find the element first, and the more elements, the more time it would take to find it. And then, after removing it from an array, we need to merge two parts of array to not have empty element inside the array. So, we need to copy array, and again, the time that it will take will depend on the number of elements. With linked list, we need to spend time to find the element. The more elements, the longer it would take. And when we found element, we don't need to copy all the data structure to merge it back again. Because this is not an array, this is linked list. So, we have to only change the references to the next and previous elements. Even despite the summary of big O notation between ArrayList and linked list looks similar, they would have different performance on different volume of data. That's why understanding how they work is essential to understand their performance. You are going to have a homework to find out the difference in performance on different volume of data. Now let's make a conclusion based on these facts. We have to use linked list when we plan constantly add elements at the beginning or at the end of the list. We also should opt for linked list when we want to remove elements constantly from the beginning of the list. If we plan to use container to always add elements to the end and read elements from the list, then ArrayList is our choice. But I told you that algorithm of array copying works really fast, and everything will depend on the amount of data that we are working with. I'm going to give you a home task where you would be able to test whether linked list really has advantage over ArrayList while working with not so big amount of data. But I will give you insights even before you finish that task. In majority of cases, even during the work with 1 million of elements that are relatively small objects, ArrayList still is going to be faster rather than linked list. And with regards of the business cases, I would say that ArrayList is your choice almost in 99% of cases. The rest of the cases are when you need either thread-safe container or you have millions of objects that you need to add in the beginning of the list and constantly remove them. I believe you would agree with me that it is even hard to come up with example here of such case. Time for linked list will come. When we'll talk about queues, we'll discover that linked list works the best for us if we need implementation of queue or DAG. Now let's recap what we have learned today. Today we learned how linked list works. Now we know what the node type is and how nodes are connected between each other in linked list. We had a practice with linked list and ArrayList. Now you even know how to use generics. We learned what big O notation is, and using this knowledge we compared linked list and ArrayList. Now you know in which case you have to opt for either ArrayList or linked list. And now I suggest reviewing your homework. I have a lot of tasks for you today. All of them has different level of complexity, but nothing what we didn't discuss. So the first exercise is to test and compare the performance of ArrayList and linked list. It is not complex from the coding standpoint, but it is also good for you to practice with creating objects of different types, declare variables, and to remember in which case you have to use which container. Here is the guidance what methods should be created and methods declarations. And here operations that I'd like you to test. We are going to insert different number of elements into the beginning, middle, and at the end of the list. We'll test these operations with 100, 10,000, and 1,100 elements. Also, we'll test removal of elements from the beginning, middle, and the end of the list. We'll perform the same operations with ArrayList and linked list. And we'll measure how much time execution of specific method takes with ArrayList and specific number of elements and linked list. After you're done with coding, I want you to fill out these tables. You may see that these tables have different rows and columns based on which list implementation you used and what operation you did. If you are wondering how you can measure the time of method execution, here is a small hint for you. You can capture time before some method execution, after that call some method, and after that calculate delta. This value you can insert into the table. After you finished, you may compare your results with my results and to evaluate the trends. I don't want to make any conclusions right now, primarily because some of them we already discussed during the lesson, and the other reason is that I want you to draw your own conclusions. The second exercise here is to update existing backend system for online store. It is a console application, and you may find it in this repository in this package. This solution uses arrays. Your task is to substitute arrays with list implementations. You are provided with a sample project here. Your goal is not to break anything and to make sure that all scenarios work as expected. This task should give you a clear understanding of how you are going to use list implementations in your applications. And the last but not the least task is to create your own implementation of custom list interface. You have to create interface first with such content. And after that you have to create class and to implement this interface in it. Team, I promise you, in case you would implement these 3 exercises, you would understand list implementations like nobody else. Remember, learning programming it is about coding and a little bit about reading, but definitely not vice versa. And by the way, you also shouldn't worry in case something is hard for you to implement. We are all learning new things here. I'm going to leave links to the solution in attachments to this video. So even in case you can't complete some of the tasks, feel free to look through my solution and rewrite it very attentively. And always ask me questions in case you have any. That's all for today. Thanks a lot for your attention and have a great day. See you in the next lesson.